Hello everyone, my name is Leila Hassanzadeh, and in today's video, I will explain how ARM32 assembly language works and demonstrate a small program that calculates the sum of all integers from m to n. So let's start with the question, what is ARM32? ARM32 is 32-bit RISC architecture, which stands for Reduced Instruction Set Computer. It is designed to execute simple instructions very efficiently, which is why it is widely used in smartphones, embedded systems, and even some EOT devices. So in ARM assembly, everything happens at the register level. Now I will share my screen to show you the instructions and the code. So what is our goal? We should find the sum of numbers from m to n. In my case, I will use it m as 1 and n as 3. So the final result should be 1 plus 2 plus 3 is equal to 6. But in this exercise, we're not allowed to use traditional branch instructions like B. We should only use move PC. So we will simulate looping using program counter manipulation. In other words, we'll change where the PC points to make it jump to a specific instruction. So the idea is, instead of B loop, we use move PC, like some address, to jump it to the label. So the code computes that address dynamically in registers. Now let's go to our code. So we'll start from third line. This means that it sets R0 to 1, and it will act as our loop counter. Move R1 3, it sets R1 to 3, which is our upper limit. Then move R2 to R2 0. It sets R2 to 0, which is our accumulator, like running total. Then sets R3 to 4. This will be later used in manipulations, multiplications that controls the jump distance. So next, we'll see the label loop, which is followed by compare R0, R1. And what it means basically, we subtract R1 from R0, but we don't store the result. It's just a set of conditional flags. And as we know that those flags are negative, 0, carry, and overflow. So they're used to decide which conditional instructions run next. In ARM instructions, it can be made conditional, so no separate branch needed. In our next line, we see add LE, move LE, move GT. So what does this suffixes mean? LE stands for execute if less than or equal. GT, it means execute if greater than. So addl R2 means we add R0 to R2 only if R0 is less or equal than R1. Then we should increment R0 by 1 only if R0 is less or equal than R1, which is why we have number 1 here. And then we set move LM R4 number 8 and move GT R4 number 2. So what this means? This means that if we're still looping, R4 is equal to 8. If we're finished, R4 is equal to 2. And this variable R4, it will become the offset that controls how far we jump next. So in our next line, since R3 is equal to 4, as it is written here, so since R3 is equal to 4, the effect of this line would be that if R4 was 8, it will become 32. But if it was 2, it will become 8. So this program now computes 2 possible jump distances, whether it's still looping or it's finished. So 32 bytes backward or 32 bytes forward. And if it's backward, we should loop again. If it's forward, we should exit. Now, what is happening? In our next line, move R5 PC, we store the current program counter into R5. So if R0 is less or equal than R1, we should sub LE R5, R5, R4, which is subtract R4 from R5, moving backward in the code. If R0 is more than R1, we should add GT, or add GT R5, R5, R4, which means that we should add R4 to R5, moving forward in the code. And finally, we have move PC R5, which is actually like jumps to the new computer address. So, and then our loop ends. But what we are doing, why is this line needed? Basically, at this point, we should stop to loop. And R4 is basically distance from compute R4, R1, R0, and R4 is basically the distance between loop and end. So when the loop ends, the code executes CVC, SVC2, which is supervisor call, invoking the kernel with syscall number 2. In a typical simulation environment, it serves as a exit instructions. So this is end of our code. But now let's look how this program will work in C language. So this is our code in C language. And in this code, we're also using 3 variables. which are R0 is equal to 1, R1 is equal to 3, R2 is equal to 0, and here R0, it also represents the current number we're adding, R1 is upper limit, and R2 is our accumulator, which again stores the running total. So starting from the next line, we have our while. While R0 is less or equal than R1. And this means that we should keep looping as long as R0 is less or equal than R1. So the program will keep just repeating the same statement inside of this loop until the condition becomes false. And inside of this loop, we also have R2 plus equal R0, which adds the current value of R0 to R2, and then R0 plus plus, which is here R0, it increases by 1. And from here it goes again here, and loop continues until it's false. So 1 plus 2 plus 3 is equal to 6. The same result is at the end. So this like simple C code, it computes the sum of all integers from R0 to R1 using while loop and accumulator variable. And in our ARM assembly version, this is basically the same thing, but like we have in C code, we have high level instructions like constructors, like while loop, and we also use conditional instructors and manual program counter control to basically achieve like the same logic at the hardware level. So normally in ARM, we can just use like B changes B changes PC automatically, but here we calculate next address and assign it to the PC. And the key idea is to use move PC instead of branch instructions. So at the end, let's check our code. So as you can see, it works, and one by one. When it goes to the 16th line at GT, it again starts from the beginning of the loop, does it till the end, then again starts with the 8th line, goes to the 16, and it continues like repeating itself until the value is true. So as you can see. So this is basically it. Thank you so much for watching till the end. See you soon, and bye.